Okay, so we just looked at, just reviewed a few things. We looked at data types, which we had done before, if I'm not mistaken. I think you have already done data types. You know,
Yeah.
yeah, they talked about data types. I did a general review of statistical measures, which we have done before. It was just like revision. Since we are going to really start delving into inferential statistics, I wanted to be sure that everybody remembers the foundation, before we move on. So we looked at measures of central tendency, just talked about, we didn't do calculations. I just did a general reminder, just a few calculations anyway. Mean, median mode, standard deviation, variance, the formulas in Excel, you know.
Yeah.
So I just did a brush up on that. And then we looked at data types. Okay, these are the data types. Generally speaking, data may be classified as categorical and numerical. Under categorical data, we have nominal and ordinal. Under numerical, we have discrete, and continuous. Under continuous, we have interval and ratio data. So continuous data is actually um, those data used for measurement, where you can have decimal points. Discrete data are data that are for counting. That's like integers. Okay. The nominal data are purely descriptive. Ordinal data, they are categorical, but they can be ordered. Okay. When you have to do something like ranking, then you are talking of ordinal data. Um, then we talked about measures of position. The main statistical measures are measures of central tendency, measures of variability, also called measures of dispersion, and then measures of position. The main measures of central tendency are mean, median, mode. Then we are talking of measures of variability. Then you talk of things like variance and standard deviation and range. Those are very basic, and they are frequently applied in data analytics, frequently applied. In fact, they are integral parts of many,
Yeah.
if not most, statistical models.
I'm in class, so
Okay,
I'm in the class. I'll get back to you.
so then we have measures of position. A measure of position determines the position of a single value in relation to other values in a sample or a population data set. Unlike mean and standard deviation, descriptive measures based on quantiles are not sensitive to the influence of few extreme observations. Now, it's not like measures of position, sort of, they function like something like a scale that divides the data into sections. For example, if you take something like quartile, for example, quartiles divide the spectrum of data into 4 parts. Is that right?
Yeah.
Percentile divides data into how many parts?
The center.
Yeah,
Is it two
100,
or 100? Okay.
derived from
Percent. Yeah, yeah.
percentage. Yes.
Yeah, 100, yeah. 100.
Yeah. So the 25th percentile is what quartile? The 25th percentile, if you convert it to quartile, what would that be?
Before,
If you convert the 25th percentile to quartile, what do you think it will be?
let me see.
What quartile would that be?
Just a moment. Is it one?
Thank you. Yeah. That would be the first quartile.
Yeah.
That's good. So the most common measures of position are percentiles, quartiles, and standard scores, also called z-scores. We're talking about competence percentiles and quartiles. They are usually commonly grouped together and called quantiles. Quantiles. Okay. Then z-scores, sorry, standard scores are also very important. And standard scores are based on standard deviation. They are based on normal distribution. Okay, based on normal distribution, right? So as we get on, as we get along, we are going to along the line, we are going to be working with these z-scores a lot. Okay, deal with z-scores and other measures of position. Okay. By the time we are looking at data transformation, we talk about z-scores, we talk about others too. Mean mass transformation, rank, decimally scaled scores, and z-scores. Just trying to brush up the fundamental theories before we begin to delve in from the next class. So the normal distribution is a very important distribution in analytics. Normal distribution, also known as the Gaussian distribution, is a probability distribution that is symmetric about the mean, showing that data near the mean are more frequent in occurrence than data far from the mean. So we can see that's the shape of the normal distribution. You can see that the middle is kind of highest. What this is saying is that more data concentrate around the center, around the average, around the mean. In graphical form, the normal distribution appears as a bell-shaped curve. And you can see between -1 standard deviation to +1 standard deviation, we have about 68.2% of the data. Between -2 standard deviation and +2 standard deviation, we have 95% of the data. And between -3 standard deviation and +3 standard deviation, we have 99.7% of the data. Okay. What this is simply saying is that more of the data are around the average. And it's so with a lot of things in life. For example, people with average height are more in number than extremely tall people or extremely short people. Isn't it?
Yes.
Yeah. People that use average shoe size, they are more in number than people that use very large size or people that use very small size. Okay. So objects, things tend to cluster around the average. Things tend to talk about marks. People